Okay, so imagine this for a moment. What if the universe isn't just vast, but layered with possibilities we can't access, structures we can't perceive, and realities that might exist right next to us without ever touching ours? Number 10. The infinite bubble bath. In 1980, physicist Alan Guth proposed a solution to some of the biggest problems in cosmology: cosmic inflation. The idea that right after the Big Bang, the universe expanded faster than light. It solved multiple inconsistencies at once, but later, physicists like Andre Linde took it further. Much further, they asked a simple question: what if inflation never stopped? In this model, space is still expanding somewhere, continuously creating new bubble universes, each one with its own physics, its own constants, its own version of reality. Our universe would be just one bubble in an infinite foam. And here's where it becomes unsettling. In an infinite system, every possibility happens, not metaphorically, mathematically. There could be universes where everything is slightly different, or radically different, or completely unrecognizable. But there's a boundary. These bubbles are separated by expanding space, faster than light, meaning no signal can cross, no information can travel, no connection is possible. So even if infinite realities exist, we are permanently isolated from all of them. And that introduces a strange tension. Infinity might be real, but completely inaccessible. Number 9. The Mother Universe Physicist. Lee Smolin proposed something unexpected. What if universes reproduce? In his theory of cosmological natural selection, black holes don't end reality, they create new ones. Each black hole could be the beginning of a new universe, with slightly different physical constants. Over time, universes that produce more black holes produce more offspring, and that creates a kind of evolution, but not biological, cosmic, which leads to an uncomfortable possibility. Our universe might not be optimized for life. It might be optimized for black hole production. Life could be a side effect, not the goal, and that shifts perspective in a subtle but powerful way. We tend to interpret the universe as something that allows us to exist. But in this model, we exist inside something that doesn't need us at all. Number 8. The brain collision. In 1999, physicists Lisa Randall and Raman Sundram proposed that our universe might exist on a brain, a kind of multi-dimensional surface, floating in a higher dimensional space, sometimes called the bulk. Other brains could exist nearby, completely invisible to us. And in some models, the Big Bang wasn't the beginning, it was a collision, two brains meeting in higher dimensional space, releasing enormous energy, resetting everything. And if that's the case, it might not have happened just once, but repeatedly. A cyclic universe, expansion, collision, reset. Not a mystery in the traditional sense, but a model that reframes the Big Bang as one event in a much larger process. Number 7. The simulation server farm. In 2003, philosopher Nick Bostrom introduced the simulation argument. If advanced civilizations can simulate reality, they probably will. And if they do, there could be far more simulated realities than real ones. Statistically, that raises a question. What are the odds we're in the original? But there's another layer that's often overlooked. If simulations exist at scale, they require resources, processing power, energy, infrastructure, which implies not just one simulation, but potentially many. And that reframes the idea, not as a single constructed reality, but as part of a system, a network, where realities could be created, paused, or ended, not necessarily by intention, but by limitation. And that introduces a different kind of uncertainty. Not Are we in a simulation? But what determines whether it continues? Number 6. The parent dimension. In 1919, Theodore Kaluza proposed adding an extra dimension to unify physics, later expanded through theories like string theory. Today, some models suggest the universe may have more than 4 dimensions. We only perceive 3 of space, 1 of time, but others could exist, hidden or inaccessible, and that leads to a conceptual shift. Our universe might not be the whole structure, but a slice of something larger, a projection. And while this idea often gets dramatized, the scientific version is more restrained. Extra dimensions, if they exist, are not necessarily accessible or inhabited. They're part of the mathematical structure of reality. Still, the implication remains. What we perceive as complete might not be. Number 5, the void of true nothing physics often talks about empty space. But empty space isn't truly empty. It has structure, energy, quantum fluctuations. So the question becomes, what would true nothing be? Not space, not time, not even potential, just absence. This isn't something we can observe, because observation requires existence, but it plays a role in philosophical and physical discussions about the origin of the universe. Some models suggest the universe could emerge from quantum states that resemble nothing, but that nothing still has rules, which means true nothing might be impossible to define. And that's the key insight. The concept itself breaks down when we try to describe it. Number 4, the observer civilization. The Drake equation suggests there should be many civilizations in our galaxy, but we haven't found them. One explanation is distance, another is timing, but some theories suggest something else. Advanced civilizations might move beyond their original universe, not physically traveling through space, but transitioning into different frameworks of reality, higher dimensional models, computational systems, unknown structures. This isn't confirmed, but it reflects a pattern in technological thinking. As systems advance, they tend to move toward greater abstraction and efficiency. If that applies at a cosmic scale, then silence might not mean absence. It might mean we're not looking in the right place. Number 3, the ancestor reality. In 1957, Hugh Everett proposed the many worlds interpretation of quantum mechanics. Every quantum event creates branches, multiple outcomes, all occurring. Some interpretations extend this idea further. What if realities form layers, not just parallel, but hierarchical, where some are more fundamental than others? This isn't experimentally verified, but it raises a philosophical question. Is reality uniform or structured in levels of description? Physics doesn't currently require hierarchy, but it doesn't fully rule it out either. Number 2, the dreaming entity. Some philosophical traditions describe reality as a kind of dream, not literally, but as a way of expressing dependence on a deeper structure. Modern interpretations sometimes revisit this idea in more abstract terms. What if consciousness is fundamental? What if reality is tied to observation in ways we don't fully understand? This doesn't imply a literal dreamer, but it does highlight something important. Our experience of reality is mediated, filtered, interpreted, and that means what we perceive as stable and objective might be more dependent on perspective than we assume. Number 1, the recursive cosmos. In 1931, Kurt Gödel proved that any sufficiently complex system contains truths that cannot be proven within it. To verify them, you need a larger system. Apply that idea to the universe, and something interesting happens. If reality is a system, then understanding it completely might require stepping outside it. But any outside would be another system, which would require another, and another, an infinite regress. This isn't a prediction, it's a limitation. a boundary on what can be known from within, and it suggests something subtle but powerful. There may not be a final explanation, only layers of deeper ones. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look, subscribe, and keep listening to the silence.